Well, hey, we're back to do some more log and base E work. In this example, we're going to be looking at how we can use the log properties, power property, product property, quotient property, to expand and condense our logs. And what we do will actually just depend on what the instructions tell us to do in the problem. So probably we're going to look at something that looks like this. So it'll probably just say, let's see, here we go. It'll probably say something like this: write as a single log. So I would imagine that on all of these, we're going to just be using those properties to condense. We won't be expanding if we are trying to write it as a single log. We're going to be taking all those properties and then using them to go from multiple things to one thing. And so we would call that condensing. Alrighty. So let's just get started. Suppose it looks something like this: 6 ln of 8 minus 2 ln of 4. Note it doesn't say solve. You don't see a variable. It just says write as a single log. So we're just using the properties to rewrite from an expanded form to a condensed form. 6 ln of 8, 2 ln of 4. And so you come over here and you think, wow, what are some of the properties that I know? And again, the three big ones: power property, product property, quotient property. So look and see, you've got some telltale signs. One of them is this subtraction sign. So you should relate the subtraction sign with the quotient property, because remember, it all goes back to exponents. When you divide with like bases, you subtract exponents. So log values are just exponents. And then the other one, you should see these multiple factors out front, realizing, hey, I'm multiplying there 6 ln of 8, obviously 6 times the natural log of 8. And think about the other rule, which is the power rule. So if you can, before you get started, take a look and see, am I adding or subtracting? That'll give you the big hint, right? And then is there a number out front that I need to use the power rule on to get this condensed? And so, yes. So let's start out then by using the power rule. And this 6 will come up here to be the exponent on 8. And this 2 will come up here to be the exponent on 4. And let's rewrite that. ln of 8 to the 6th minus ln of 4 squared. Okay, so that's a little bit more condensed. I still have a subtraction sign going on. So I think about the quotient rule. You see why it's so important. If we were in class, I would say you have to memorize these. You do have to memorize them. If you're going to use them successfully, you really need to have them right up here. Otherwise, you can have them written down, but then it's like you're hunting and pecking and trying to find it. So the more comfortable you are with them, the more you'll recognize them, and then you'll just know them. And it all goes back to exponent rules that you were first exposed to in either 7th or 8th grade. So now we're going to use the quotient rule. And we'll rewrite it as the natural log of, and this becomes the argument, 8 to the 6th in the numerator divided by 4 to the 2nd in the denominator. So we've got two things here. In our final answer, we probably want it, instead of saying the natural log of 10 bajillion, you've got two things you can do. You can look at these and say, hey, you know, I could put 8 in base 2 and I can put 4 in base 2. So you probably would rewrite it that way. That's one way to do it. or you could say 8 to the 6 divided by 4 squared. You would get a large number, and then you'd be like, oh, well, can I rewrite that using expressions? So anyway, a couple of different ways. If you just do this, and that's acceptable. If you just do this, so on here you would say what? 8 to the 6 divided by, 8 to the 6th, which is 262,000 and change, divided by 4 squared, which is 16, and we get 16,384. So you could do it that way. In other words, just divide inside the argument right here, and you would get the natural log of 16,384. And again, is that written as a single log? It is. Is that technically correct? Yeah, it is. But when you look at this, you're like, oh man, that's a big number. I wonder if I could write that using a base and an exponent. And you could. So would I accept this? Yes, I would. But I'm going to show you another way that we could do it, that you actually can simplify this a little bit. So bear with me. Over here, we're going to do some side business. You should recognize that 8 and 4 are both multiples of 2, and therefore you can write with 2 as the base. So another way to write 8 is 2 to the 3rd. So 8 to the 6th is the same as 2 to the 3rd to the 6th, isn't it? And then 2 to the 3rd to the 6th, when you take a power to a power, you multiply the exponents. So I get 2 to the 18th. Right? We're going to call this our side business. And then I've got 4 squared. So if we come over here, 4 squared is the same as, how can I write 4 using base 2? 2 squared. All right. To the now what? Second power. Because 2 squared is the same as 4. And then there's the 2 on the outside. So 2 squared to the second power, again, when you take a power to a power, you multiply your exponents. So that would give me 2 to the 4th. And what's the advantage of doing it that way? Well, we don't need our calculator, which that's one advantage. If you can think, the more you think and process exponents and logarithms mentally, the more you really understand them. And instead of just like, I don't know, she did this, so I'm doing it, right? Just following some rules, which may be how some of you feel. And I get that, because I know it tends to be that way until you just like jump in head first, so to speak. So why is this a good thing? All right, well, we can rewrite this. So we'll say, so we now have what? The natural log of, and instead of saying 8 to the 6th, we're going to say 2 to the 18th. And instead of saying 4 squared, we're going to say 2 to the 4th. Oh, that's pretty handy, because look, my bases are the same. I'm dividing so I can subtract my exponents. So now guess what? We're going to use the quotient rule, this time the exponent quotient rule. And now I have the natural log of 2. Come on, pen. It's being kind of unresponsive. Sorry. There we go. 18 minus 4 is 14. Okay. 2 to the 14th. If you put that in your calculator, guess what 2 to the 14th is? 16,384. So now, is there another way to write that? Well, yeah, we can use the power rule again. And rule, and then write 14 times the natural log of 2. And that's pretty swift. All right. So I realized, because some of you, and this is common to hear with students say, well, I don't know. Do I need to keep going? Am I done? Do I keep rearranging? So I'm trying to write it as a single log. So again, you could have gone here. But the reason I'm showing you both ways is because you're going to be doing odd problems. And the book is going to do it this way and probably end up with it like this part of the time. And so you're like, do I do it this way or this way? Well, if you got this answer and you're like, yeah, and then you looked it up in the back of the book and it had this, you'd be like, what the heck? I have no idea. So I just want you to see both ways. I'm not trying to add to the confusion. I know I'm not, I promise. I just want you to see both ways. All right. Okay. Let's do one more that's not quite as, that is not maybe not as, uh, not quite as long, but another type of problem. All right. So let's come over here and I will do, I think there's too many things happening at my house right now that require internet. And so my pen is being very slow. All right. So same thing. I'm going to write it as a single log. And we have 2 times the ln of 5 plus 4 times the ln of 2 plus the ln of 5y. My dogs are barking. Can you hear them? Somebody's walking by. So again, my expression, I'm trying to get it down to a single log. Notice what's happening here. I have multipliers out front in front of these two, which that should clue you in on the power rule. Good. And then I have plus signs in between, which should tell you you're going to use the product rule. So let's use the power rule first. The natural log of 5 squared plus the natural log of 2 to the 4th plus the natural log of 5y. And how is that legit? We use the power rule for logarithms. Okay, so now I just have these plus signs to deal with. That's the product rule. And it says that the sum of the logs is the same as the log of the products. So I'm going to say the natural log of 5 squared times 2 to the 4th times 5y. 5 squared is 25. 25 times 5 is 125. 2 to the 4th is 16. And 125 times 8 is 1,000. So 125 times 16 is 2,000. And we're done.